Okay, so if I have a set A and R is the relation, binary relation, so that means it's acting on A. So we call the relation an equivalence relation if it's all three of these things. Okay, so it's called an equivalence relation if it's reflexive, symmetric, and transitive. Okay, so once we have this equivalence relation, what we like to do is make equivalence classes, and this is how we denote it. It's like these square brackety things around a number. So the class of A is the set of all elements X that are in A that are related to A. So whatever I have, so this is not going to be unique, whatever letter or number I put in here. It's all the things that are related to the A. Okay, so let's go with this one here. So I want to find the equivalence classes. So I'm looking at these numbers and here's the relation. I don't know what it is. They're just telling me in ordered pairs. So here I see 0 is related to 0. So I'm going to give it the name 0. Okay, so that's the equivalence class of 0. And so let's write down what is in the set that's related to 0. So I see 0 is related to 0, 0 is related to 4, 4 is related to 0, and 4 is related to 4. So there's only two numbers in this equivalence class. Now this is not unique. This could be the class with the number 4. Because 4 is one of the elements of this set that's called the equivalence class. So it could be called this or it could be called this, but these are the elements of the equivalence class. Okay, looking further, excuse me, so I can see 1 is related to 1, so I'm going to make the class that's got 1 in it. What else is related to 1? 1 and 3, 3 and 1, 3 and 3. So everything in this set is related to each other. So again, this could be called the equivalence class 3, or it could be called the equivalence class 1. It doesn't matter. So is there any other numbers in here? So I see 0, 1, 0 and 1, and 3 and 4. I don't see the number 2. So let's see what's happening with 2. Oh, 2 is just related to itself. So in the equivalence class of 2 just has the number 2 in that set. All right, so I am going to let you all play with this one so that you can figure out what is in the equivalence classes where 4 divides x minus y. But anyway, I'll let you figure that one out. Ooh, I'm going to let you do this one as well because I know you love Power Series. All right, so let me go and do this one here. So I'm going to I've got the numbers written out, and I would recommend you do that for this one. Just write out the numbers just to see them. So what am I looking for? I'm looking for where 3 divides m minus n. So I'm looking at 5 and 2. So if I take 5, take away 2, 3 divides that, right? So I'm just going to give it the name 5 just because I just decided to start here, no particular reason. So in this equivalence class 5, I'm going to have the numbers 5 and 2. And then what other numbers will 3 divide? So if I take 2 and negative 1, right? 2 and negative 1. And if I take 5 and negative 1, will 3 divide that? Yes. So everything in here, any combination, subtracting these two, right, m minus n, I will have 3 divides that. And so what else can I put in here? I think, let me just use a different color here, negative 1 and a negative 4. That gives me a negative 6, 5, wait a second, 4, negative 1 and negative 4, that gives me a 3, sorry about that, yes, so negative 4, okay, so those are the numbers. So if I take any combination of these, that 5 divides those two things. Okay, so, and again, this could be called the equivalence class of 2, or it could be called the equivalence class of negative 1, right? So that it's not unique. Okay, so let me erase my little markings here. So then moving on to the next equivalence class of 4. So what numbers can I combine with 4 so that 3 divides it? So I know 4 and 1. So 4 take away 1 is 3. So 4 and 1, and then 1 and negative 2, and then, excuse me, negative 2, and so take away a negative 5, right? Whoops, I meant to put parenthesis things there, right? So this is equivalence class 4. So then let's see, I do not have all the numbers taken care of, right? So I have the number 3, right? So I'm looking to see what numbers I've taken care of, right? Because every number has to be in an equivalence class. So I've gotten 5 and 4, and I have not gotten 3. Okay, so let's see. 3, take away 0, right? So 3 and 0, and then, well, I said that and wrote it differently, didn't I? And I think negative 3, right? So I got these 3 numbers, and I have 5 and 2 and negative 5 and negative. Yep, I have all numbers taken care of, right, in these 3 equivalence classes. So the deal is equivalence class, equivalence classes on a relation. There'll be no intersection between them, right? There's nothing in common between any of these, and or they're going to be exactly the same, right? So I have this set, right? The set A, and I'm not going to write all the numbers in there, but there's the set A. So here would be the equivalence class 5, here would be the equivalence class 4, and here would be the equivalence class 3. There's nothing in common between them, and they form a partition. Remember, partition breaks up the whole set into things that do not intersect. And so if I add, or take the union, not add, but take the union of all the equivalence classes, I get the whole set A, and the intersection is 0. All right, so let me do this one here. So here I'm telling you this is the set, and there is a relation R, and I'm telling you that these are the equivalence classes. So it's like saying, they didn't label it so, but it's like saying the equivalence class of 0 is 0, 2. So they're wanting you to, they want me to label the equivalence class, so that's it. I labeled the equivalence class, and find all the ordered pairs. So what are all the ordered pairs? So all the ordered pairs would be all the ways that these two things can be related to each other. So 0 is related to 0, 0 to 2, 2 to 0, and 2 to 2. So those would be all the ordered pairs that come out of that equivalence relation. Okay, so then here, so this would be the class 1, right? That's labeling the class. And then now let's go find the ordered pairs. So here we would just have 1 related to 1. That's it. That's all I've got. Okay, so now let's go this one here. So I'm just going to label it 3, or you could label it 4. It doesn't matter, right? So this would be this class. So then I have to write all the ordered pairs out. So 3 is related to 3, 3 to 4, 4 to 3, and 4 to 4. So those are all the ways that these elements here can be related. All right. You get to do those 2.